Okay, so this is a paper model of my locking mechanism, and I've got this piece here, and I sort of talked about the development of internal structure a lot, and sort of this piece would run up, well, I say this piece, I mean quite a few of them would run up the length of my L piece, and within this the locking piece would move. So this is meant to resemble the body of the locking mechanism, so it'd move in and out as the user sort of, you know, pulls it and unlocks it and then locks it again. But as I've said, the problem is that I haven't got something preventing the desk, the L structure slipping down this, so forcing this up anyhow. So this has sort of forced me to develop a sort of lock, and this is what I've sort of produced in response to that. And this idea is that this spins on a central point within the body of the locking mechanism and turns like this. So you'd have that. Now, if you just focus on this piece a minute here, and you can imagine my hand to be that. So this gap here would be where the body of the locking mechanism moves in and out. It would catch on here like this, and that would prevent the L structure from slipping down because this bit blocks it. Now, what I have learned through modelling this, because it's gone wrong, is that the thickness of this will have a direct impact upon the thickness of this. But also what I've sort of been thinking about now is the level of friction that will occur between turning. I mean, this would have to be dead on. And it's friction that can occur here and here that I think will be a problem. But not only this, as I've said before, I wanted my handle to be centralised, but this locking sort of mechanism requires a pivot point at the centre of the locking mechanism, which means that my sort of handle for the user to interact with this would have to be here in the middle of the body of the locking mechanism. So it means that I can't have my handle centralised anymore.